Okay, good day. As one of the coverage of the course syllabus, right now we shall discuss about modeling functions. So when you say modeling functions, it is like an introduction to word problems that involves functions. And in modeling functions, you will be given worded problems to which you have to understand in order for you to be able to construct the function that defines the statement of the problem. Okay, so before we proceed to our examples of modeling functions, I want you to print first or secure first your own copy of the module that I have uploaded in the Blackboard, which is about modeling functions, so that you'll be able to catch up with the examples that which I am going to discuss. Okay, so all right, in modeling functions, okay, there are steps that you could follow so that you will find it easier to model functions. So the first step, as stated in your copies of the module, is for you to understand, picture out, or draw the statements in the problem. So you could not form or model a function if you do not understand the problem itself. Okay, next is you have to determine the known and unknown quantities. Now, there will be quantities that will be discussed in the problem, and you should know also, very important, that you should know which of it is or are the independent and dependent variables or quantities. Okay, because with you could not form the function if you do not know which of the quantities or of the variables are the independent and the dependent variables. Okay, and then number 3 is that it would help if you will be listing down the given data. And the next is you could now start to formulate or model the function that is being stated. And then the last is you will have to solve the problem if there is something that you have to solve using your modeled function, and also to make a conclusion. Now we'll start with our first example. So let me read first our first example. Okay? The volume of a gas having a constant pressure is directly proportional to the absolute temperature. Now, we will stop right there. We will first consider this first phrase of the problem. So, you have there the volume of a gas. Now, volume of a gas, or simply the volume, is one of the quantities. Okay? And then, volume of a gas having a constant pressure. So, we have there constant pressure. Now, pressure is also a quantity, but it was said to be constant. Okay? You have to take note of that. Now, with these quantities, we have to assign variables for us to have for us to be able to formulate functions easier. Okay? So let's say volume, letter V will represent the volume, and for the pressure, let's say we'll have P. Okay? And then next, the volume of a gas having a constant pressure is directly proportional to the absolute temperature. Now we also have what you call, or another quantity that is being mentioned, is the absolute temperature. Okay, so let's say that will be represented by capital letter T. Okay, now again, we'll go back to the first phrase. So the volume of a gas is directly, or having a constant pressure, is directly proportional to the absolute temperature. Okay, since pressure is constant, then therefore the pressure does not affect the volume of the gas or all other quantities. Okay, so we will expect that pressure is not included in the function. Now, the volume of gas having a constant pressure is directly proportional to the absolute temperature. So we could see there that volume and temperature has a relationship wherein volume is directly proportional to temperature. Now, this talks about proportionality. So, when you say directly proportional, let's say you have the volume of a gas is directly proportional to the temperature. So, this is a symbol of direct or symbol of proportionality. Now, if we are to convert it to an equal sign, then we could have volume equals K times T, where K here acts as what you call the constant of proportionality. Okay, so this will be our initial equation. Okay, now when you say inversely, this one is if it is directly proportional. Okay, when you say inversely, let's say A is inversely proportional to B. Okay, so this is how you present inverse proportionality. Okay, pag direct is ganito. Okay, so pag inverse, you have the first quantity, then symbol of proportionality, and then you have the reciprocal of the other quantity wherein it is inversely proportional to. So in equations, that will be A equals K times 1 over B. Okay, but anyway, this is not part of the problem, but I just want you to know what it means to say inversely proportional. Okay, now this is our initial equation. Now with this equation, we could see that the volume is the dependent variable. Okay, and then the independent variable is the temperature, because as you see in the equation, if we have a given value of the temperature, then we will be able to get the amount of the volume for a given temperature. So temperature here acts as the independent variable. Okay, now with this understanding, we could have V is equal to function of T, since the volume depends on a given value of the temperature. Okay, so next, wherein V is equal to K times T. Now, for us to have a function wherein only the dependent variable and independent variable is not constant, we have to be able to get the value of the K, constant of proportionality, so that we'll be able to completely form the function that involves V as the function of T, and of course T as the independent variable. So how do you get K? Now that will be with the help of the next phrase. Now, the volume of a gas, again, reading the problem, the volume of a gas having a constant pressure is directly proportional